Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic and repair procedures for DTC P0456, which indicates a very small leak within the EVAP system of Honda Accord models from 2012 to 2017. The EVAP system is designed to contain vapors from the fuel tank, preventing emissions into the atmosphere. A very small leak can trigger the DTC without necessarily causing drivability issues, but it requires inspection and possible repair. Diagnosing this involves checking components like the fuel fill cap, vapor recirculation hoses, EVAP canister, canister purge valve, and the fuel tank itself. Proper troubleshooting will help prevent excess emissions and ensure vehicle compliance with environmental standards. This guide will walk through the diagnostic steps, verification methods, and repair procedures specific to Honda Accord vehicles affected by this condition. The final visual step involves inspecting the fuel fill pipe and vapor return pipe for leaks, cracks, or disconnections. Damaged or loose connections can compromise the seal, causing small leaks. Also, inspect the fuel tank unit gasket and the tank itself, as deterioration here can lead to vapor leaks. Tightening or replacing damaged parts restores system integrity. If the visual check finds no issues, further testing of the fuel tank assembly or fuel cap system is warranted. Properly sealed fuel fill and vapor lines are vital for preventing emissions-related DTCs. After completing repairs, reinstall all parts in the reverse order of removal. Turn the ignition off, then restart the vehicle and perform the leak test again by running the EVAP function test through the HDS. Ensure the DTC does not return, confirming the leak was effectively sealed. Resetting the ECU is also part of the verification to clear stored codes and allow the system to relearn. This final step verifies that the repair has resolved the small leak and that the vehicle's EVAP system is now functioning correctly without triggering the DTC again. Preventive measures help avoid recurrence of the DTC P0456 in your Honda Accord. Regularly inspect the fuel fill cap for tightness and proper fit, replacing it if any deterioration is evident. Maintaining the EVAP system components, including hoses and canister, ensures long-term sealing and prevents leaks. Conduct periodic emission system tests as part of scheduled maintenance to catch potential issues early. This proactive approach preserves vehicle performance, reduces emissions, and helps prolong the lifespan of EVAP system components, ensuring compliance with environmental standards. In summary, diagnosing and repairing DTC P0456 involves a systematic approach to identify small leaks in the EVAP system. Starting with simple checks such as the fuel fill cap, then progressing through hoses, valves, and the canister itself allows for an effective pinpointing process. Following the detailed troubleshooting steps ensures that no small but critical leaks are overlooked. Proper repair, including replacement and retesting, guarantees the EVAP system will function correctly, preventing emissions and maintaining vehicle integrity. Understanding each component's role and location in the system enhances your ability to diagnose issues accurately and perform effective repairs, ensuring your Honda Accord remains compliant and environmentally friendly. The first step involves inspecting the fuel fill cap, which is crucial since a loose or improperly sealed cap can cause EVAP leaks. The cap must be properly installed with the correct tighten-to-click specification, meaning it should turn an additional quarter turn after it clicks. This ensures the seal maintains system integrity. If the cap is not tight or not the correct type, fuel vapors could escape, triggering P0456. If the cap is damaged or doesn't seal properly, replacing or tightening it is necessary. After repair, a verification step should be performed to confirm the leak is resolved. This step is fundamental because many EVAP leaks originate from simple, overlooked issues like the fuel cap. Next, a visual check of the fuel fill cap seal A and the fuel fill pipe mating surface B is essential. The seal must be intact without cracks or deterioration, and the mating surface should be clean and free of debris or damage. The tether cord C should not be caught under the cap, as it can interfere with sealing. Damaged seals or surfaces can cause tiny leaks that activate the DTC. If any damage or obstruction is found, replacing either the fuel fill cap or the pipe may be required. Verifying the integrity of these components helps eliminate fundamental causes before moving to more complex checks. In this step, turn off the ignition to prevent system pressure or vacuum interference. Then, visually inspect the fuel tank vapor recirculation tube for poor connections, cracks, or damage. This tube helps reroute vapors from the fuel tank to the intake manifold. Damage or disconnection here can cause small leaks that trigger the code. A damaged or disconnected vapor recirculation tube must be replaced to restore proper function. Proper inspection ensures that the vapor path is sealed and functioning, preventing false leak indications. Addressing issues here can resolve leaks originating from the vapor recirculation system. The fourth step involves testing the EVAP canister purge valve for leaks. Disconnect the vacuum hose from the purge valve. Then connect a T-fitting, vacuum gauge, and vacuum pump rated from 0 to 30-inch hay. Apply about 2 kilopascals or 0.6-inch hay of vacuum, slowly. Then observe whether the vacuum holds for at least 1 minute. If it does, the purge valve isn't leaking. If it doesn't, there could be an internal leak in the valve or in the lines connecting it. A leaking purge valve allows vapors to escape, creating a tiny leak. Replacing a faulty EVAP canister purge valve restores proper vapor flow control and seals system leaks effectively. In this verification step, turn the ignition to on and use Honda's HDS diagnostic tool to clear existing DTC P0456. Then, run the EVAP system function test via the HDS inspection menu. The goal is to see if the system passes the test without errors. If the test passes, the system is good, although intermittent faults can still cause issues, so further inspection is advised if the vehicle exhibits related symptoms later. A failed test indicates a persistent leak or malfunction. Performing this step ensures an active diagnosis rather than relying solely on previous codes, and it helps confirm whether the observed problem is temporary or ongoing. This step involves isolating the EVAP canister vent shut valve to check its operation. Disconnect hoses from the canister, then connect a vacuum pump and a vacuum gauge. Turn on the ignition and run the EVAP test with the HDS, selecting EVAP CVS on mode on the single solenoid. Apply vacuum until the FTP sensor voltage hits 1.90 volts. Let the vacuum sit for a minute and observe if the voltage increases more than 0.2 volts. A proper increase indicates the vent shut valve is functioning correctly, whereas no significant change suggests a malfunction. Accurate diagnosis at this stage helps pinpoint the leak source before replacement, saving time and effort. Transition to testing the EVAP canister vent shut valve by switching to EVAP CVS off mode. Disconnect the fresh air hose from the canister and plug the vent shut valve port to prevent airflow. Apply vacuum as before and monitor the FTP sensor voltage. If the voltage increases more than 0.2 volts within a minute, the vent shut valve is operating correctly. If not, the control valve may be faulty or the line may have an obstruction. These tests confirm whether the vent shut valve is allowing proper vapor flow control, which is critical for detecting leaks in this segment of the EVAP system. Visual inspection of the EVAP canister purge line and associated components is essential. Look for cracks, leaks, or disconnections between the canister and the purge valve. Damage here can cause tiny leaks that trigger the code. Also, check the EVAP canister itself for cracks or deterioration. Ensuring the integrity of these parts helps eliminate common leak sources. If issues are found, replacing or repairing damaged lines or the canister ensures the EVAP system maintains proper pressure without leaks. Please like and subscribe to the channel. See you next time.